Hi. Sorry I'm late today. I was helping a friend do some resin printing stuff, but I'm here now. You'll see gradually that I start coming later and later to the stream just because did Bellum not come on? I don't know. Maybe Bellum went to sleep early. Bellum was here at 9:03 and 9:23, and now Bellum is not here anymore. Still working on those Blinky learner kits. I don't know why my resistors aren't coming in. Okay. I'm gonna be doing a battery vending machine. I have to get this done by Friday. Like, I feel like I can do it, but like, it's so far away. I'm not sure if I can. So that's the thing. That's the deal. That's the deal with it. I know it looks like a really ugly cube right now, but I swear it's gonna look better in later. So the plan for this is I need to find a way to neatly screw this on and assemble the electronics. So what I'm thinking is I make a piece that just clips onto the side here. I'll make it screw on, basically. And that's going to be the plan for this. So first I need to like make this a little wider. I'm going to make it a cube, I believe. 53 millimeters. Yeah, that's fine. And I'm going to make it screw in from the bottom. That's not fine. 29 millimeters. So if I want to get this to, let's say, a decent amount, let's say 50 millimeters. Probably just 21 more. Yeah. Yeah, 21 more. Okay. The way I'm catting this is so stupid. It's like the worst catting you'll ever see anyone do. $50 millimeters. And then the width is 85. Because yes. Okay. But I think the plan is I'm going to cut a notch into the top here so that I can screw it in. So whatever the distance from the bottom, I'm going to match it from the top since it's mirrored. This is about 9.076, so I'm going to draw a line at the top. Let's get you to 9.076. Oh. This. Oh, hey, Bobby. This is due in 2 days, and I am not ready. Oh, that is too much off the top. I'm just gonna pull it back a bit. Yeah, that'll work. That'll work. Okay. Then I just need to make a piece that clips onto this part so that I can assemble the electronics inside. And then drill some holes on the bottom to catch it. This is the worst cat you'll ever see. I'll be honest. You know what? I will also. This is 7 millimeters. 7 millimeters is enough to drive a M3 screw in, I believe, because it's gonna be 6 millimeters diameter. Okay, so then I'm gonna edit the sketch. Look at all these like extrude operations at the bottom. Like, what is this? Disgusting, right? Okay, how much do I want to dimension this? 7 millimeters, 7.5. 7.5 it is. I believe it's 7 millimeters. Okay. I hope it is, because I don't want to get this wrong. Alright, so then I just make something that clips onto this part, and then we're golden, I think. Maybe. So there's going to be a hole on here, on the top, on the side, and then through the bottom on the corners. And that'll secure it in place. And then the electronics will go on this face, so I'm going to go ahead and make some holes there for it. Okay. I never remember how like far I make these things. How did I have how far did I have these holes? I wonder. I don't know, okay. So if I have, usually in Altium, my default go-to PCB is, actually it doesn't matter. I'm just gonna make it 5 millimeters. I will deal with that later when it arrives, when the issue arrives. Five millimeters should be more than enough, honestly, for M2.5 by 6 millimeter screws. What is the electronics going to run or control, by the way, I host you? Oh, thank you, Team KDK. So the purpose of this electronics is to connect to the battery that's in here and provide an output of a data line and a power line. So the power line is supposed to charge the battery that's being plugged into this device. And the data line is supposed to extract different data values from the LiPo battery, such as the cell-by-cell voltage, the full voltage, the amount of current, the internal temperature, stuff like that. And then these two power and data lines are going to go into like a central host database once I have all these power modules created, and then they'll have like a big microcontroller, like an Arduino Mega, just to analyze all the data. But basically, the input is the LiPo battery, and the output is a power and data line. Are you having your AC running? Yes, yes. I completely forgot. I have to turn on my Belty. I'll do that after the stream. Yeah. So what this is a battery storage chamber and an information, like a host for information, basically. So battery storage, so allow it to charge when it's not used, make sure it stays safe, so when it gets above a certain voltage, just cut it out from the circuit, and then also to get information from it using a data line. M2.5 by 6mm, which means like it's gonna go 4mm deep. I believe. No, 3. Because the board itself is almost like 3mm. So you want to swap all the battery to read their data. Yeah. So the battery is going to be placed inside of this capsule using a robotic arm. I don't know how accurate this is going to be. The accuracy part, I'll worry about that later. But the battery gets slotted in. Right. So the battery gets slotted in. These two little thingies on the side will clamp the battery shut so it doesn't move. The battery will go into the bottom here where it has a little connection port, and then it'll go straight into this chamber where internally there are the male side that connects with the battery's female side. So that's how it makes the electrical connection, and the side arms just hold the battery in place while it's being tested. Then it's wired to the back, in which the back actually processes the data or like exports the power. So that's where all the power stuff is. To show the sketch again. And then from this output, because there's going to be 8 of these in like a circular arc, their power and data line is going to go from this area and just like simplify it into like 2 lines going into the center. And then in the center, we're going to hook the data lines up to a bigger PCB, and that PCB is going to go ahead and give us the power and data values for what we're analyzing. Let me just like screw this up a little bit. Alright, so this is going to be printed out, and the reason I have this kind of design is that I want to have a separate piece just to fit on top of this bigger piece. Sorry, the smaller piece. Or something along those lines. So the bigger piece will act kind of like as a case for it. So let me go ahead and make that right now. It's going to be an offset plane, be like offset to this area. I'm going to make the side frame first, so get the dimensions for that, and then make the upper frame. So I guess this offset plane doesn't even need to exist. Okay, I should have made it like offset plane from here. Yeah, so it's going to be like this rectangle. Okay, and then I can project this rectangle inside so I don't end up clip that. Okay. And then I believe it's going to be extruded out this one, which is 85mm. Okay. So then I'm going to go ahead and extrude this out by 85mm. Alright, and I'm going to make a sketch on this face. So then it's going to be 7.5mm from each edge. I'm going to get copyright strike for that. The next song in my playlist, if I don't loop the chill game music, is copyrighted. So like, the last time I played that, Twitch muted my stream for like 5 minutes after the fact. What more data do you need more than ESR voltage, capacity, and leak? Temperature, and that's about it, pretty much. And then one of my teammates wrote like a AI thing, or like he wrote an algorithm in order to calculate the battery health and give it like a grade. So yeah, we have like a huge array of data points that it's going to extract from the battery and provide it with like the status of it. Also, we wanted to implement some sort of cycle tracker in order to track the cycles of the batteries being in a machine, but that wouldn't work unless you find the IR, right? Are you gonna put it in a temperature chamber? No, it's just gonna have a thermal resistor hooked up to like the internal parts of it. So it's gonna be it's gonna be a thermal resistor combined with the current reading, and the internal resistance. And we use the sensor fusion to provide us with a pretty accurate value of what the voltage is. I actually don't know how far I should extrude this. Let's see. $5 millimeters. $7.5 millimeters. Okay. I have to bring it back 2.5. Yeah, so roughly this will be the cap. Roughly. I need to extrude these two parts out. No, don't join. Oh, that was close. No, I have to undo the move. What is this measurement? Oh. Okay. So then in order to fit it, we have to like add artificially proc tolerance. So there we go. And then I think internally we should have tolerance on this edge. And the other edge. And maybe the top as well. Now, you see, you're not supposed to do this in CAD, but I just do it just because. And then now it should be correctly toleranced. I shouldn't have tolerance on this bottom half, actually. The bottom part of it should be. Yeah, because then it wouldn't be flush with the top. But like, I highly doubt anyone would notice 0.5 millimeter worth of tolerance. Highly doubt it. Okay. Hi, Bellum. You know all scientific needs the temperature test to add, else your next measurement will change during doing temperature change. Bellum, you're late. No, Chris was late. He is always on when he's streaming. Yeah. There will be like at least 3 ways to test temperature, I think. That's what I told them. Because temperature is one of those things where it's very variant, and in general, for like all temperature purposes, the reason we measure for temperature is just to like prevent it from expanding. So it's more like a threshold thing, not really more of an accuracy thing. So if it's like too high for some reason and it's like a consistent average over like X amount of time, think about the printer time you're saving by removing 0.5 millimeter. Yeah. Oh yes, all that 3 minutes of time saved printing by like not. Bam. Wonderful. No one will know a difference between this. I have to add 2 holes for the data wires, honestly. Okay. So this is me This is me making a thing. Now I have to give you a thing. 42.5 millimeters. 21.25. The way you do this is you make a center rectangle here, 15, maybe 20, sure, 10. Just give it room. All battery work with chemicals and work differently at different temperatures. That's why there's a bell curve where you get the most out of your battery at temperature range. Yeah. That is correct. I'm not going to argue against that fact. And then boom. I was taught this trick by one of my friends, who's no longer here. Because he graduated, not because he died. I just realized how bad that sounded. Okay. Basically, I'm going to punch 2 big holes in the back. Why did it select everything? Yeah. I'm going to punch 2 big holes in the back. So that, these holes are way too big. Maybe like 10. Yeah, maybe like that. That's a little better. Okay, so punching 2 big holes in the back, so that the power and data line can exit safely. And then I got to do all the holes now. Yeah, holes. I love screws. Okay, I'm going to do the holes on this side first. So internally on the battery chamber. So over here. First, I'm going to make a center line so I can line all the holes up. And then I'm going to make a center line in the middle. Look at how helpful Fusion is, telling you where like all the center points are and stuff. And the edges I'll actually have to measure. So it'll be 5 millimeters. It'll be 5 millimeters. What a helpful program Fusion is. All components is divided within a certain specific temperature. I think is at 25°C, but it says in the data sheet. I will have to look at the data sheet for that to verify it. I am not sure of that exact number. TMKDK. Okay, so that sketch is done. These holes are going to be all the way inside. So these are going to be M3s, M3 millimeters. And they're going to be M3 by 10s. No. Yes. No. M3 by 12s. I'm going to 5 millimeters deep. 6 millimeters deep. Okay. It's going to be 3 holes on the top. And then 2 holes on the side, I believe. So if I have 2 holes on the side, then I have to space them out evenly. So this is 31.424 divided by 4, and that's going to get me 7.0 7.856. Why is there no point in the center? I'm gonna need so many screws just for this. I love screws. Like the thing they print are never gonna fall apart because of how many screws there are in each design. We waiting for the Lock Fafa switches to on shape. Oh my goodness. I'm waiting for the day I switch to on shape. That'll be the day in which Fusion doesn't offer a hobbyist license and like a free Fusion anymore, and I'm just gonna be very sad. That'll be a sad day for me. Okay, and then Miu and Fusion doesn't offer free software. What are we doing? Construction, plane 6, and then mirror. I hate the fact that I'm not abusing the mirror function more in this project. Come on. Come on, select the series. You know you want to. Yeah, there you go. Why did I select 4 objects? I just want the screws. There you go. Oh my goodness. Let me select the plane. Okay. There we go. So then 1, 2, 3, 4, 5, 6, 7 screws on the top and the sides. And then it's going to be more on the bottom. Alright, so these are going to be... How thick is this thing? 10 millimeters. Do I have M3 by 16? No. No, I don't. Okay, I guess it's going to be M3 by 20s. Real deep in there. I'm going to do the electronics for this later, too. This can be the center point for this line, though. Well, that's not helpful. 7.5. Oh, it's just 3.25. Wait, 7.5. 3.75. I can't math. Okay. And then it's going to be same here. Same here. Which means I'll have a point here, here, here. And then maybe at the centroid of this location to lock it in place. So 25 from the top. I think I'll put one here, here, another one on the bottom. This thing is not going anywhere, I'm telling you. There are 14 screws locking this back piece into place. It's not going anywhere. then, let me check my notes for the dimensions of these screws. I feel like I should be memorizing these by now. Okay, so the top is 6 millimeters. No, this is 6 millimeters. The total depth is going to be 7.5 millimeters. That height is going to be 2 millimeters. The bottom width is going to be 3.5 millimeters. Aha! I did it right this time. Oh no, it's 10 millimeters. Just kidding, I didn't do it right. I spoke too early. Okay. Look at how many screws are in this thing, on this bad boy. I'm gonna be careful with like this though. No, it's not gonna go 10 millimeters deep. It's gonna go 12 millimeters deep. So 8 and then 4 millimeters into it. Yeah, okay. Hi, Canarsa. It is a stream. Yes, it is indeed. Okay, now that I have those things done, now it's time to unhide the other body. What do I call this thing? I have the battery chassis, and then the battery... the battery carriage and the battery container. Battery e-case. Okay. The e-case needs some holes here. I'm going to start with the bottom ones, because I think that's easiest. Just going to hide that, make a sketch, and then unhide this, project that onto there, hide it again, finish the sketch, make holes. These will be 4 millimeters deep, I believe. Wait, no. Before I do anything, I'm gonna save those settings. Yeah, I'm gonna save those sketches. No, just kidding. I'm too lazy for that. I was gonna save the sketches because I'm gonna use them later, but I'm already here. Okay. M 3 millimeters. I wonder if that's too far in. What depth did I make it? No, 4 millimeters. Okay. Gotta make sure my screws are intact. Okay, and then I can unhide this. I need the screws on top and then on the sides now. Okay. Yes. And then project this. Sketch. Okay, now these are going to be the fancy holes. Now I got to dimension again. So they're going to be 7.5 millimeters deep, which is correct. 6 millimeters, 2 millimeters, and then this is 3.5 millimeters. Okay. I should go all the way through. Yeah. Alright, and then I gotta do the ones on the side. So in total, for this back piece here, there's 14 screws holding it together, which I think is a little... struggles. Alright. The amount of time I spend doing these things, do some of these things. Hold on. bottom there is fine. The one on the other side, I'm gonna just mirror it because I'm smart, and having things parameterized to one another is pretty darn good. Okay. So, to keep this in total, there are 14 screws holding this together. 7 on the top, 7 on the bottom. Is it overkill? Yes. I'm not even gonna deny that, but hey, kind of works. Okay, so now this is the battery container that contains the bigger one, which is gonna take absolutely forever to print. Then I just have to make one more thing to make this a little bit more complete than just a big box, big box right now. I have to make some way to hide these solenoids, but the problem is I don't know if they are accurate or not in terms of being able to screw in. How big are these? So these are going to be 6.75 millimeters. Hmm. 3 by 10 should be fine, I think. Okay. I'm gonna cut out a portion of the this container right now just to test this piece before I go any further, because I want to make a little wall to the left and to the right just to wire these solenoids in. I'm keeping exposed in the outer shell like this, and if I go any further, I'm gonna lose that. I will go ahead and make the fiducial marker heading though. So on the top here, there will be a little bit of a fiducial marker thing happening. Not directly on the sketch. I need to build a little fiducial marker holder. If the battery can't expand, it'll burst into fire. It is able to expand inside the battery carriage. Just like not by a lot, not by a concerning amount. I did consider that when I when I designed this thing. Not enough. What do you mean not enough? Box needs to be able to open up with pressure. It does open up with pressure. Well, not exactly the pressure you're mentioning. It does. It allows us to open up from the top and the bottom, which is usually what I think is battery's gonna do. If it expands to the side, there's tolerance on the side where it can wiggle back and forth. And this thing basically comes apart. Like if I pull on this, it's gonna snap. Like this thing is really fragile, the top part, and it's designed so that if the battery does expand and want to blow up, the top part will break off and allow the battery to rest inside, being expanded. It's really fragile, the top here. Like, I can't tell you, because they printed this on Belty, on the top, and the bottom is, the bottom part is kind of, like, sagging down, because, here, I don't know what the best way to describe it is, but, like, imagine, imagine this, alright, imagine this. So this top piece here, I can't use a mouse. Imagine, like, if I actually knew how to use a mouse. So this top piece here, I printed on Belty, like, in this orientation. So that as it was printing the bottom piece, right? Oh my goodness! It's a giant bridge, basically, yeah. Oh, KillX07, thank you for the follow. Welcome. Basically a giant bridge, and it's a really fragile giant bridge that Belty is printing all the way across, because there's no supports. Which is why it's like really fragile, and if I pull hard enough, it'll break. Pure IRL. PR's just left. Okay. But yeah, this is what we're working with. Okay. I have to get belty printing. Belty's start printing a few things for me right about now. Okay, anyways. I can't believe I'm saying this, but I want a third belty. Like, if I'm working on 4 projects at once that all require belty's not enough. Maybe next year. Maybe next year I'll think about getting another one. Okay, what was I doing? Right, this thing. Okay, so here's the plan. I'm gonna make a little cut in the design. 10 millimeters left and right. I'm gonna hide the battery chassis, hide the battery chamber, and just like slice this in 2 pieces. Okay, and then we're just gonna print this bottom piece here. Because we need to see if the tolerances are right for this, which I'm very sure. Do you have the power to run one more? Yes, I do, actually. This belty is not running power through my room. It's running power to the outside. That belty is also running power through the door I have in the back to the outside. Like, I know, like, it doesn't seem like it, but, like, actually, none of the belties are using power from my room right now. I'm stealing power from the outside fuse, you know, to put it in here. I'm also starting to get, like, a lot of these cases, the black cases, to put my printers in, because they get so dusty. These get incredibly dusty. I had NIFC clean them, like, for, like, 5 hours straight, and it was still dusty. Power theft. So you cheat with your electric bill. No, I don't steal from outside. I steal from, like the living room's fuse, so that I don't blow a fuse in this room. It's still my power. But, like, I cheat the fuse, basically. I'm not actually stealing power. That would be illegal. Okay, so I need to print this piece. Yes. I'm gonna print it with belty, I believe. That container. That solenoid slice. Actually, no, I can print this with a regular printer. Just pull this up. And I also need to print one more of my. I'm just gonna print out here. Actually, no. I didn't connect any of the power cables yet for that printer. Oh. I have been renovating. Just slightly. Okay. I like how every time this opens up, every time this USB drive feature opens up, the monthly renovation, yeah. I mean, like, you guys saw the stream. Like, I basically had just the sweatshop at the beginning of my Twitch stream, and it slowly just grew out of control. I had to put my resin printers outside my room because these cases took up too much space. But I will no longer be fumigating my room, so that's a great thing, I guess, maybe. Welcome back, Kondarso. What am I looking for? Okay. I need to print this piece to make sure that it works properly. And then in here I can just make this invisible and remove this slice. And then I need to go ahead and redo this one. So I made a little bit more of a bigger opening. That's 11 millimeters now. And then hopefully this one is sectioned off correctly as well. So many sketches. I don't know how I'm gonna finish the Friday. I am. Which sketch is it? Highlighted a sketch. Which sketch did you highlight? I honestly have no idea. I'm gonna hope this works. In general, this hole doesn't need to be longer though. I don't know which sketch it was from. I have to go on my timeline to find it. But I also need a print of one more of these. I've printed so many of these now. I think just my printer hates me because it's printing too much of those things. Okay, it fits on here. Battery should fit in the middle. These clamp things should fit pretty well. And I'm gonna see if I can screw them in. And I'm gonna see if the tolerances are right and everything. And this will take 1 hour 58 minutes. Good. Very good. I still haven't done the electronics part of this. It's just the amount of work I'm gonna have to do. The amount of all-nighters I have to pull for the next 2 nights. Only a bit stressful. Okay. Well, I'm gonna let that print. I'm gonna try to find out where this is. I want to extend it back to 5 millimeters, compared to 4 millimeters. It's a little bit safer for me. I'm gonna get a print started. Yeah. So once I verify that this is correct, I can move on. I don't want to modify this further before I verify that it's functioning. Because I'm going to create an extension out from the side that allows them to like house this area. Oh, I also have to blow a hole into this wall. Maybe like a circular thing. Okay, so like a little special sketch. Okay, and then I'm gonna $50 millimeters, so 25, and I believe it's 25 on the side too, right? No, it's not. It's 20.25. So 20.25 from the top, and then 25 from the side. Alright, so this way, I'll have access to the battery chambers there. And I'll just mirror this to the other side. Okay, good. That way I can wire the solenoids into the middle of this thing. Okay, so while that's working, I'm going to go ahead and make another object on the top here, and these are going to be the AR tags. So I'm going to use 100 millimeter by 100 millimeter AR tags, I believe. That's the regulated size of them. Oh, that's really large. Just kidding. Maybe 40 millimeters. 40 millimeters by 40 millimeters sounds nice. Okay, so I'm going to make a offset plane over here. Make a sketch. I'm going to make a larger square, or like a one. Like up here. So this is going to be 40 millimeters by 40 millimeters, and this is where the AR tag is going to reside. And I'm going to get a border of 5 millimeters on each side. That's going to be 50 millimeters by 50 millimeters. I want this to be a little larger. Yeah, okay. Just so that it has room to recognize it. So we're gonna like spray this, make this a border paint whites or something like that. Okay. I think I need this offset like 5 millimeters back. Really. Okay, there we go. Now the sketch is offset 5 millimeters back. I just heard my printer turn on, so that's good. I'm gonna extrude this all the way back about 5 millimeters or 10 millimeters. Yeah. And then take a sketch and then extrude this small thing -5 millimeters back, so that I can place the AR tag in the middle there, and have it be recognized, which is good. Okay. And then I'm gonna need to find a way to attach it to the chassis here. So ways to attach things to other things. That'd be screws. Alright, we're gonna put some screws on here. AR tags, Chris blowing his entire student loan on printers. Money will be spent to... I don't have student loans. I mean, I go to Cal Poly. I don't really need student loans for that. The amount of all-nighters I need to pull for the next 2 lights. Yes. Have you tried committing to smaller projects? I thought all of Chris's salary went to electricity. You know what? That's probably true. I'll have so much electricity to write off by the time I finished this job, actually. So, the math is, I estimate, because I have a power meter underneath my wall socket, so I can calculate how much power I actually use. It's about 1 cent per 1 hour of printing. So if I print for 24 hours, it's 24 cents. Someone recycled an RPi 3B plus of a SIM card at the scrapyard today. Oh my goodness! Does it work? Condarsa, does it work? You know how rare those things are? It's like a gold mine. Got it in an unknown condition for $3. It just booted. Very nice. I remember like I had some experience like that, or Pyromike did actually, and it just didn't boot at all. So that was a tragic incident. What am I doing? Okay, I think I'm gonna push this 10 millimeters back just so I have room to make the base of it. It booted into a slideshow. Oh no. Maybe it was, that's why it was scrapped. Okay. And then I'm gonna make an offset plane from here. Make it like 5 millimeters up. I do need to commit to smaller projects that don't take like an arm and a leg to pay for. Or an arm and a leg that will never get paid for. I'm never getting paid back at this point, right? Alright, rectangle. $70 by $25. It gave the birthday minute. It looks like this thing was hooked to my eyes! I mean my ears! Oh my goodness, Bellum, thank you for the 100 bits we pay you. Yes, you guys do pay me. You guys pay my bills. Pay my non-existent bills. What? Oh. Hold on. That looks relatively even. I'm gonna say it's even. I think it's even. I'm gonna assume it's even. 5.25. It's not even! Okay, that one looks even. Okay. That one's even. Okay. Then, the edges here. 7.5, good. I've learned my lesson. Yeah, it has a set the border 7.5 on all sides, which means you guys want to know what it means? I hear with my eyes. Okay. Which means you guys know what this means? This means I can do a little bit of trolling. M3 by 8s. Did I read that right? Do I have M3 by 6s? I do. M3 by 6, M3 by 8. I'm gonna use M3 by 8s instead. Okay. And then extrude this thing all the way up. No, I need to make that smaller. For prettiness purposes, I need to make that smaller. I got a 100 watt 4 ohm resistor to 100 watt 4 ohm resistor. Is it like a big block of metal? Like whenever something that high, it's usually in a big block of metal. All right. What am I doing? What do I do? Jumped. I'm literally gonna print this like right side up. No one's gonna stop me. This looks ugly. Not gonna lie. Okay, I need to make a thing. Okay, that looks slightly better. It looks moderately better. I'm gonna do a fancy pattern. .25. Oh, math is beautiful. It's even. It goes into it perfectly. Oh, hold on. I see what's happening here. Alright. Beautiful. Now watch this. Wait. Okay, this is a solid shape. I clicked out of that for no reason. Now I have to do it all over again. Efficiency. 1, 2, 3, 4, 5, 6. I need 4. I need to go over here. Okay, that was right. Okay, now all I need to do is someone just come in and turn off the AC. If you like Matthew Cat, you can use OpenSCAD. Okay, that is even worse than than the other one, in which I'm not gonna name. OpenSCAD is terrible. I looked at it once and I was like, never again. Wait, hold on. Wow, designs in CAD. Who would have known? Amazing. It's a lattice. Okay, now for the screws. So how many screws do I actually need to attach this thing? Probably just 6, right? How about FreeCAD? I did this. What is this? A punch card? What's a punch card? It's a card with holes in it? I mean, it looks cool. Oh, or maybe is it one of those like music things? It's a pre-floppy storage device. I see. Oh, it's rotating. It's rotating. I think my immediate went to those like music boxes where you put like a card in it and then you like rotate it and it starts playing music. I want to make one of those one day. It'll be fun. I started off with FreeCAD until I found out that one of the axes had an offset and nothing worked, but it was also an older version. I made the punch card in SCAD. I see. You like math, Narsa? Probably extrude that too. I still have not implemented to nurse's pull request. I haven't done a lot of things. I've been busy, guys. I apologize. I need to put up positrons. Like, I took upon myself to do another like small project with positron, and I'm making him a watch. That's fun. And I also have to give him his stitch as well. It's just been so busy. Oh, this next week is gonna be horrible for my sleep schedule, which is already non-existent. I'm literally sleeping like in the middle of the day for 3 hours and then not sleeping for like the rest of the time because I'm working. Alright, I basically just found all my points. Wrath. Openness kind is good for generating random patterns, but also not good at making round surfaces. And also scale design use holes in the design with just a number. Right, because everything's parameterized, right? Oh, this is 5. I remember my first engineering teacher trying to teach me about parameterization and how it's good for CADing, and like I never used it. He did teach me about projections though. Projections are useful. It's bananas about I made round surfaces. Oh, it does look like that. Oh my goodness. These honestly scare me. Nice spacebar, Condenser. I got a bunch of these power resistors. I think these are 2 ohm 100 watts. These things. They're pretty scary. It's a lot of power. It's a lot of responsibility. Yeah, it's a big one of those. Yeah, it's like it's dad. So M3 by 8 is gonna be. Wait. The top is 5, and it's 3, and 5 on the bottom. No, it has to be an M3 by 6. Yeah, it's M3 by 6. Okay. Good. I think I can actually, like, bevel this now. So let me just fillet everything. Fillet the front. Fillet the back. Fillet all the sides. Open 5 is good. Make it look very nice and attractive. Actually, I don't want to fillet the inside. I want to chamfer that. Chamfer. And I can fillet the outsides. Fillets. 2, 3. Didn't fillet the bottom side. Dang it. Oh, the bottom side doesn't get filleted either. fillet, fillet, fillet. Oh, it's not gonna like me when I do this. Watch. It's gonna yell at me. In 3, 2, 1. Oh, it didn't yell at me. Oh, that's the first. Normally it would scream bloody murder at me. It doesn't like it when I do like random things like that. This should print out in one piece, right? Looks like I can print out in one piece. Okay, I'm gonna put it big fillets on the corners, or the corner edges. .5. And then just leave it like that. No fillet on the top because they're screws, and then basically, boom, AR tag done. So this will go on every single one of the carriages, just so that it has an identification, way of identification, and that'll be that, pretty much. I can't believe I just spent 20 minutes of my life making that. AR tags are very useful, I like them. Okay, nice. Alright, so like 1 out of like 8 of the features I want to implement are done. One of the things are printing right now, so I'm gonna go ahead and see. Can the IDs be drawn animals? What do you mean, like a lion on the AR tag and have it recognize it? I got some one be a chicken, one be a cat. One be a horse. Yeah, if you like write up a neural network to for OpenCV to recognize that, or like for your code to recognize that, sure. All right, so I'm gonna make these side modules once I verify that this is printed, and then I'm gonna be done with this. And then I just gotta make this thing is gonna have wheels on the bottom, so I'm gonna make some more like designs on the bottom to add wheels and capabilities like that, and then make the entire round thing. I think I can just start on the round thing very soon, but I have until Friday to do this, so I think I'm gonna work on the electronics for the rest of the night, and then work on this CAD during stream for tomorrow. And I'm just gonna turn in the CAD drawings and tell them I'm gonna print this later, because each one of these things is gonna take a while to print. I can already foresee it. All right, that'll be it for me for stream today. Gotta go take care of something off stream, so we'll do that. Can be both, maybe it can. All right, we all know who. Oh yeah, are we going to? Who are we rating? Vellum. There was that one streamer we went to rate yesterday that I forgot about. Was it Sid or something like that? Yeah, he ain't live. All right, we all know who we're going to. Bellum is gonna stay here. I think he's tied down. Bellum just has like a lock on my channel. He's not going anywhere. Okay. I think that's it for me today. I'll have now. So thank you guys so much for watching. Hope you had a great time here, and have a great rest of your night. And I'll see you tomorrow. All right. I hope I'm awake by tomorrow. Okay. See you then. Bye for now. Bye. Go say hi to Kenshi.
get